All right, I just wanted to go over number 101 with you, the word problem about population growth. One like this will be on your quiz. So they give you the derivative, dp dt, the derivative of population, which is the rate of change of population, which is really just population growth, the growth factor of population. So it wants us to write an equation that gives the population at any time t. It wants us to find p of t. So you're given the derivative, it wants you to find the original, which means you have to do the integral. Okay, so we have to integrate that function above, dp dt. So we have to do the integral of 3,000 over 1 plus 0.25t dt. Now to do this, we're going to need to do a u substitution, as we've been seeing in most of these problems all the way along. So we're going to set our denominator equal to u, which is 1 plus 0.25t. We do our du, which the derivative of 1 is 0. The derivative of 0.25t is just 0.25 dt. Now, we need to adjust, because we need our integral to look like this, du over u, right? Then we know the integral that is ln of u, right? But we have a problem here, because right now we have 3,000 dt as our numerator. Okay, so we need our du to mirror that. Right now our du is equal to 0.25 dt. We need it to equal 3,000 dt. So we need to figure out what factor we need to multiply by to go from 0.25 to 3,000. So we're going to have to multiply by 12,000 on each side. Right? If we multiply by 12,000, let's just erase this. If we multiply by 12,000 on each side, right, then we get 12,000 du equals 3,000 dt, because 0.25 times 12,000 is 3,000. Now we have a match, 3,000 dt, 3,000 dt. So now we could rewrite this integral in terms of u. So instead of 3,000 dt, it's equal to 12,000 du over u. Well, that's just really 12,000. You could pull that 12,000 out. It's just a constant times the integral of du over u, which we know is ln u, right? Plus c. And then we plug back in our u expression. So this becomes 12,000 ln of 1 plus 0.25 t plus c. All right, now we're not done though, because it also gives us this right here. At t equals 0, the population is 1,000 bacteria. All right, so that is essentially the information we need to solve for c. That means, so if pt equals this whole thing, right? And if our t value is 0, our population equals 1,000. So basically, if we plug in 0 where the t is, 1 plus 0.25 times 0 plus c, we could solve for the c value, aka it's essentially what it is the y-intercept, the initial value. So when you do all this algebra here, 0.25 times 0 is 0, 1 plus 0 is 1. You get ln of 1, which is really just 0. So it's 12,000 times 0 plus c. So it really just becomes 0 plus c equals 1,000, which is really just your c value. So long story short, that 1,000 is your c value. Okay? So now we have our function, and then the last question it asks us is find the population when t equals 3 days. So if p of t equals this whole 12,000 ln of 1 plus 0.25 t plus 1,000, it wants us to figure out when t is equal to 3. So p of 3 equals, just plug a 3 in, and plug it in the calculator and get your answer. So ln of 1 plus 0.25 times 3 times 12,000 plus 1,000. You get 77.15 and change. You could round that though. Well, that's it. That's the population right there, 7715. And that's how you do the work.